Hello, my name is Nithish. I am from third year from Engineering Physics branch. So today I am going to present digital counters using 8085 microprocessor. So can we actually make counters using 8085? Like a counter, like I am just displaying in the presentation. Yes, we actually do because if you see the 8085 is 8-bit microprocessor, they can like giving some suitable instructions. We can display on counter of suitable time. The LCD display can be connected to the microprocessor for showing the timer. And here we can also design counters of suitable time limit as it can be given as an input to the LCD microprocessor. So let us see how it actually works. Here I am showing the flowchart. So here first of all we will begin by initializing the counter with the 0, and immediately we will display the counter in the LCD display, and next we will wait for some time. This wait for some time can be adjusted by calling the delay function, and afterwards we will increment our counter and we'll see if the counter is reached to the limit we have kept. Like if I kept the limit as maximum 8 bit number, that is 255, then it will check if it is reached that point, then it will stop the uh, program. If not, then it will again display the next digit as already the counter has been implemented. So in this way, uh, the entire counter, how like this is how the counter works. So next, here I have discussed about the delay. So how to introduce this delay part? You can actually introduce it in many different ways. The main thing is like this: like you have to initialize a counter. Take the counter here. If you have the large counter, then the delay what we are generating will be large, and because so here it is the working like we initialize with some value and we decrease that value, and we see if the values become 0. If not, then we will again go through the mission, like the program doesn't stop, so the program again executes that to decrease the value up to 0. When the value has become 0, then it actually returns. So it returns to the main function, and uh, like I have shown here. So the after executing this delay, uh, then it goes to implement the next. In this way, the entire program works. So now, how we actually do it in the 8085 microprocessor. So uh, here you can see the program. Like first of all, I have initialized the counter NBIC00H. So and I have taken accumulator, and I have moved the contents of the to the accumulator, and immediately I called the display, and after that I called the delay function, and I incremented by using INR mnemonic. So and next I have immediately checked if uh, the value has become reached to FF or not. How I checked? I checked with the CPI, like it is compare immediate from immediate value. I mean, so it compares with the FFS. If it is equals to FFS, then Z and Z will become fail, and the function will go to alt. So if it doesn't come to FFS, then actually it goes to the back here. So it will again call display. So in the way I have shown the flowchart, it proceeds in that way. So this is the delay subroutine. You can see. And so I have a display. If you connect a display to the HDR microprocessor, and then you can give it as an output port, and then it takes it as an input, and it will display the current count. Here, if you see the delay function, I have taken a number set 255, decimal. So, and I'm trying to, so actually you can take up to 16-bit digit. We have taken only 8 bit, but still uh, you can take more also. So if you decrease the DCX D, so you are decreasing actually the memory location, and immediately you're moving the uh, contents of it to the accumulator and checking if the total value we have taken 1650, it is has taken 0 or not. If it has become 0, then we actually return to the main function and we start executing our main function. So this is actually how it works. So in the uh, if you want to say uh, how we actually calculate the delay, actually the delay can be adjusted. If you want to make a counter of large delay, it is up to your choice. So that is why I said 8085 can be acted as a uh, delay sorry counter very nicely. So here you can see if the microprocessor is operating at a frequency of 2 megahertz, then we actually know, after knowing the frequency we will be able to calculate the time state for each machine cycle. So it is zero point 0.5 milliseconds. Okay. So, like how many time seconds, how many t states will require if you want to generate a at least say zero point 0.5 seconds gap. So, by calculating uh, how much time each opcode takes, then we'll come to see like uh, some this much amount of count. Here I have written 416610. So this much amount of uh, count should be given as an input to the microprocessor to generate a time of 0.5 seconds. I mean, it's a delay of 0.5 seconds, 0.5 seconds. So not only these counters are there are other counters like BCD up counter. So here also the same thing happens, but actually an extra thing of adjusted for decimal can be added, and you can also see that values of can be changed up to 00 to 99, and there will be also a BCD down counter in the similar way. Here also we will be calling a same uh, delay routing flowchart. Uh, so here is the code part of this BCD counter, almost the same, but here we have taken DA. This DAS especially is decimal accumulator adjust. So it actually when BCD additions will be taking place. So uh, it doesn't actually give the result we are opting for. So DAA will be helpful in these cases, and it will help us to move forward in the like program. Okay, so everything is all same. So actually, with the if you see the delay, you can actually take your function as well. You can generate delay by using 16-bit registers, or you can delay. You can generate a delay, small delay by using a single loop, or or you can use a double loop. So it's up to your choice. The delay. If you want to check how much delay you want. So here also I have calculated the delay, and you can see uh, the same thing I have like done as before. So I hope like you have like known the part, and I want to explain like how actually contact can be made from uh, using 8085 microprocessor. Thank you.